So on Friday, we were looking at all of the exponentials. And we talked about the relationship between the exponential and the logarithm. We talked about what the graphs look like and how to evaluate a logarithm. Today we're going to look at some of the properties of logs and solve some basic log problems. Alright, so here is our first one to solve. Remember, when we were graphing, we usually started out just by taking the log and changing it to an exponential. And so that's actually going to be the same strategy when we go to solve these equations. We have to first change it to exponential form. How did we do that? You start at the base, so the base of the log is the same as the base of the exponential. So it would be 3 to the second power equals 4x minus 7. And then this is an equation we can easily solve. 3 to the second is 9. So if we add over the 7, divide by 4, and we get x to be 4. We do have to be a little bit careful on these. When you are talking about the log, the base and the argument both have to be positive. The only thing that can be negative in a log is what it's equal to. Okay, so you should always check when you get your answers. Make sure if I plug a 4 in, 4 times 4 minus 7, that's a positive number, so I'm okay. If it were a negative, then we would have to say no solution. So always check on these, make sure the base and the argument will be positive. All right, let's look at this one. So if I wanted to write this in exponential form, what would we do? To get rid of the second power, we would, and when you add a square root, you need,
Plus minus, but x can only be positive.
so we get x to be positive or negative 8. Now we have to check those. The argument and the base both have to be positive numbers. So positive 8 is good, but negative 8 won't work. So my only answer is positive 8. Because that base cannot be negative. Let's do some more. So we get x to the negative 2 power equals 16 over 9. There's several options for where to go from here. What are your thoughts? Okay. X to the negative 2, you could write that as 1 over x squared. Then what would you do if you were trying to solve for x?
First multiply by x.
Okay. So if you were trying to get rid of the fractions, let's just cross multiply. So we get 16x squared equals 9. To get the x squared by itself, x squared would be 9 over 16. Then to get rid of a square, you do square root plus and minus. Square root of 9 is 3, square root of 16 is 4. Are both of those answers possible here? No. Just like on the last one, we talked about the base has to be positive. So since x is the base, it can only be a positive 3/4. Alright. Let's go ahead and do B. So in exponential form, this is 16 to the 3/4 power equals x. All right, how do I rewrite 16 to the 3/4? What does that mean?
16√3 and
It's the 4th root of 16 cubed. The 4th root of 16 is 2. 2 to the 3rd is 8. Quick check, that's a positive, so we don't have to worry. One more. Log base 36 of x equals the square root of 6. Sorry, I said that backwards. Log base 36 of the square root of 6 equals x. So that's 36 to the x power equals the square root of 6. Then what do we have to do? That would be an option. We've done problems like these before. What did we do?
But it's the same.
36 is 6 to the 2nd. The square root of 6 is 6 to the 1/2. So you have 6 to the 2x equals 6 to the 1/2. You can set your exponents equal to one another. Divide by 2 and x is 1/4. I would like for you guys to try a couple on your own. Are there any questions so far? So here are your problems. So the first one would be 3 to the 2nd power equals x. So that gives us x equals 9. The last one, 2 to the 3rd power equals 2x plus 1. To move your 1 over, you have to subtract it, then divide by 2. So you get 7/2 or 3.5 for that one. All right. What I would like to do now is talk about some properties of logarithms. All of our properties assume that everything's positive because we know that logs only work with positives. So what you need to write down for your properties, got a typo there, the product, quotient, and power properties. So the product property tells us if you have the log of two things being multiplied, you can do the log of each one separately and add those together. Same is true with dividing. You just subtract your logs. And if you have the log of something to a power, the power can come down in front. So a couple things that I really want to mention here. Notation is going to be very important. When you split these up, you have to put the log base A with each of them. With the quotient, the thing that follows the subtraction is what was on the bottom of your fraction. So anything on the bottom will have that negative in front of it. The other two things down here, they don't necessarily have a name. These are just some properties. But it has to do with, just like we talked about, what a log meant. Log base A of 1 equals 0. If I said log base 2 of 1, we talked about Friday how that means 2 to what power equals 1? Anything to the 0 power is 1. And if I said like log base 3 of 3. It's saying 3 to what power equals 3, so that's just 1. So these two aren't really properties you have to memorize. If you understand what a log means, you can figure those out as they come up in your problem. So really the three things you need are the product, quotient, and power properties. So I want to take a look at a few examples. So on this one, you might be able to figure this out. This is saying 8 to what power equals 2, and 8 to what power equals 4. But they aren't obvious answers. However, we could use one of our properties. If you have two logs being added, that means you can put them together by multiplying. So this is log base 8 of 2 times 4, or log base 8 of 8, and that just means 8 to what power equals 8? 1. Okay. On B, same idea, how would you combine those? Divide, that's 18 divided by 3. So you get log base 6 of 6, which is again 1. So look for the opportunity to use those properties. They can make your problems easier to solve. A couple other properties that we need to know. A to the log base A of m power equals m. And log base A of A to the R equals R. These are kind of confusing, but if we think about in terms of numbers, I think it will be a little bit easier to understand. Let's say I said 5 to the log base 5 of 7 power, and asked you to figure out what that meant. We talked about how to go back and forth between an exponential and a log on Friday. And this is technically an exponential because you have 5 to a power. So if you wanted to write this as a log, you start with the log. The base of the log is the base of your exponential of x equals your exponent, which is log base 5 of 7. So then we can see if these things are equal that our x has to be 7. This whole thing is equal to 7. Another way to think about it, we talked about how exponentials and logs are inverses of one another. And you know if you do a function in an inverse, they cancel each other out. So when I have an a to the log base a power, those are inverses, those things cancel, and you're just left with that n. So on the second one, a couple ways to think about it again. If I said log base 4 of 4 to the 8th power, the power property says that 8 can come down in front. So that's 8 times log base 4 of 4. 4 to what power equals 4? 1. So that's just 8 times 1, which is 8. Thinking about it as an inverse, we know the log and the exponential are inverses, so if you do both, they'll cancel each other out, and we're just left with that r. So a couple ways to think about that. So let's look at a couple properties. Does anybody know what this is going to equal? We said if you have a 3 and a log base 3. Those are inverses, they really cancel each other out. So if you drop out those pieces, you're just left with x equals 8. That was our property. So log base 4 of the cube root of 16. Any suggestions on what you want to do here? There's a couple different ways of doing this problem. Okay, we could go to exponential. So that means 4 to the x power equals the cube root of 16.
Which is just 4 to the
Okay, so a cube root is like a 1/3 power. And 16 is 4 squared. So that means 4 to the x equals 4 to the 2/3. So x equals 2/3. Another way of doing that would be rewriting that 16 to begin with. 16 is 4 squared to the 1/3, so that's 4 to the 2/3. And a log base 4 into 4 would cancel, and you get 2/3. So different ways. We can change to exponential, or we can recognize properties when they come up. Sometimes it's easier to recognize the property than others. All right. Last thing I want to do today is kind of setting this up for tomorrow. We're going to practice using these properties, the product, quotient, and power properties. So tomorrow we're going to work a lot more with expanding and condensing things. When I say expand each expression, I'm asking you to break it apart as much as possible. So if you have things being multiplied, we can do the log of each one and do what to those logs? Add them. You have to make sure you put the log base 7 on E. So it's just log base 7 of 8 plus log base 7 of 6. So on B, you have log base 6 of 12 divided by 5. What do you do?
Log base 6 of 12 minus log base 6 of 5.
Again, we can flip order on these, but you just have to make sure the one that was on the bottom is what has the negative in front of it. On C. So, on this one, let's rewrite it without a 4th root first. So that would be log base A of R to what power?
2/4.
Then properties of logs, that 3/4 can come down in front. And it's just the coefficient, so it's just 3/4 times log base A of R. D. We need to look at this one a little closer. All of this is under a square root. A square root is what power? So what I'm going to do is distribute that exponent. So 3 times 1/2 is 3/2. S 2 times 1/2 is just a 1 over T 4 times 1/2 is 2. How many times am I going to have to write my log? 3. 1 for each variable. Okay, so this R to the 3/2, what could I go ahead and do with my 3/2? So that becomes 3/2 times log base A of R. It was multiplied with the S, so plus the T is on the bottom, so minus, with the T squared, so you can bring your 2 down. Is everybody okay there? We're doing pretty good on time. I think I'm going to do one more slide with just a few more practice problems like this, and then we'll stop for today. So I just want to keep doing the same thing, expanding these same directions. So we have log base A. I have x times the square root, so when I break those apart, we would add. But technically, we don't want to leave a radical in there either. A square root is just like a 1/2 power. And if we think about our properties, what can you do with that 1/2? Now you'll notice my x squared plus 1, I'm putting it in parentheses because it's the log of that whole thing. We have rules for breaking apart things that are multiplied or things that are divided. Do I have any rules for breaking apart things that are added? No. So I cannot break that up and do the log of each one. This would have to be my stopping point. Yes?
Didn't you take out the 1/2 and make a log base A of x plus 1? So it's x squared and plus 1 to the square
To the
root.
1. Okay, here's the problem with that. If I give you like x plus 3 squared, you can't just square each of them and make it x squared plus 9. You would have to write it twice at FOIL. So that's kind of the same principle with that 1/2. You can't distribute it through because there's more than one term.
Okay.
Good question. Other questions there? Take a second and see how far you can get with the next two. These are going to be our last examples today. How many logs will you need for the first one?
3.
You'll notice I don't have a base written on this one. We'll talk more about that later, but anytime the base isn't written, it's actually assumed to be a 10. But if I didn't write it in the problem, you don't have to write it on your answer either. So this would just be log of x. It was multiplied with, so we'll do plus the log of x plus 2. Again, that's adding, so we can't break it apart. On the bottom, I have an x plus 3 squared, so we have to subtract that log. But what could you do with your square? Comes down in front, so minus 2 log of x plus 3. C. On the top, This is all under a square root, which is like what kind of power? The 1/2. So this is log base A of x squared plus 1 to the 1/2. Okay, now I have to be careful. On the bottom, you could write it as log of x cubed times x plus 1 to the 4th, but those things are multiplied, so can't we split them apart? Yeah. So my 1/2 comes down. Okay, a couple ways to think about this. When you have things multiplied, you add their logs. But because this whole thing is subtracted off, if I distribute that negative, they both become negative. Or you could think about it, they were both on the bottom. Anything on the bottom will have a negative coefficient. So it'll be minus 3 log base A of x minus 4 log base A of x plus 1. Now we are going to work more with this part tomorrow. Today your homework is only going to be the first type, solving those equations. Tomorrow we're going to finish up this section, so I'll do a little more practice with this. We'll also do some review. I'd like to do maybe a quiz on Wednesday over everything we've covered in this chapter so far. So we'll review that tomorrow and talk about what that quiz will look like before we go any further in this chapter. So here is your assignment today, page 442, 14